Hi, have you ever thought how Redis internally stores strings? In this video, we will deep dive into Redis data structures. The first most common used data structure that almost everyone has used is string. So in string, you can store any kind of data. You can store integers, strings, sessions, counters, JSON, image bytes, right? So in this video, we will see how Redis internally stores string value, how it's so efficient and highly performant as comparison to normal C strings, right? Because you might be thinking that Redis might be storing strings just like how C language does it, right? But they don't, because C strings have some limitations. So Redis introduced their own data structure for storing strings, which is very efficient and scalable, right? So before that, let me explain you why they don't use C strings. So in normal C language, how do you generally store a string? You just write characters star name is equal to, let's say, whatever value you want to store, right? So internally, it would look something like this in your RAM, where you will have contiguous block of memory and every block will contain each character of your string, right? And in the end, you will have null terminator, right? So the first limitation is getting length of this particular string. So in C language, whenever you want to get a length of the particular string, that would take almost like O(n) time, right? So that is not efficient and scalable from Redis point of view. Why? Because Redis has to deal with millions and billions of string values, right? So it's not ideal if, let's say, you want to get a length of that particular string. It has to be almost O(n) if we are dealing with strings in Redis, right? So that's why this is the first limitation of C strings. You can also assume one example. Let's say we are storing 1 MB string, right? And if you want to get the length of this particular string, length function in C would have to scan 1 million character bytes. So in Redis, it's not ideal. And second limitation is it's not binary safe at all, right? So let's assume you're storing any null byte in your string in between. So because of this, what happens is C would actually treat this as ABC only. It would not count F as a string in this, as a character in this, right? So it's not ideal for storing image bytes, protocol buffers, serialized strings, right? So it's not binary safe. So these are the two limitations of C strings. There are other limitations as well, but these are the most like high limitations which C strings have. And Redis introduced one new data structure, which is STS, which solves both these limitations, right? So yeah, before this, let's first understand some operations that you can perform in Redis CLI directly. I'll open my Redis CLI, right? So my Redis server is already started over here, and in Redis CLI, I'll perform some operations on string just to give you an idea of what is type, what is encoding, right? So let's say I store my name in name key, right? And if you want to check its type, you'll usually write type and then key name. So you'll see it's string, right? And let's say I maybe declare one more variable and I store integer in string. So again, its type will be string, right? But Redis internally optimizes this, right? It wouldn't store everything as strings. You know, it has 3 different encodings. I'll also write them down. So Redis provides 3 encodings for storing strings to optimize memory, right? So first one is integer, second is emstring, and third is raw, right? So I'll also show you some examples of this, right? So let's say if I check object encoding of name key, it would be mstrings. So mstrings encodings are generally used for shorter strings which are less than 44 bytes. So whatever value you are storing in Redis, if it's less than 44 bytes, it will always use mstrings, right? And for all the strings that are more than 44 bytes, it will use raw string, right? And let's say if you're storing a number in your string value, it would use integer encoding. So for example, if I check object encoding of counter, you'd see it would come as integer. So why Redis is internally doing this it's doing this to optimize memory storage, because otherwise, let's say if you're using same type of encoding for all the string values, then it would consume a lot of bytes in your RAM, which is not ideal and efficient, right? So that's why they introduced different kind of encodings to optimize your memory. I'll also show you example of raw encoding. So let's say you mutate your string and you append something in your key. Let's say I append my surname in this. So if you check object encoding of this particular key, you'd see it has converted into raw string now, right? So every immutable string that you store initially would always be encoded as mstring, but whenever you mutate it, it's converted into raw string. So that's how Redis internally changes encodings of your string values that you're storing, right? Now we'll discuss how these values are actually stored in Redis. So any value that Redis stores, it stores in redisObject, right? And that redisObject internally points to STS where your actual value is stored, right? So this is the internal data structure, just a high level overview. So every value in Redis is stored as redisObject. That redisObject points to STS where your actual value is stored. Let me show you how this redisObject will look like. So redisObject it would be a structure or a dictionary internally, and that structure will have a type. So what kind of object you are storing? So we are storing string, right? And what kind of encoding that particular object has? So let's say it has mstring encoding. It would store LRU timestamp. So according to the policy that your Redis has, whether it's LRU or LFU, it would store the timestamp of that particular object, like when was it last used, right? And then you have reference count and pointer. Reference count is like how many owners of that particular value that you're storing is initially. So initially it would be 1, and yeah, later on it can change it to 0 as well when it's freeing that particular redisObject, right? So you already know how to check memory usage, right? So this is the basic structure of redisObject. It will store the type of your object, encoding of the object, LRU, reference count, and pointer. So this pointer will point to another location in memory, which is STS, and this STS is also a dictionary which will store length of your string, allocation, like how many memory we have allocated to this particular string value that we are storing. It will store flags. So flags are used for defining the type of STS header. So in Redis we have different STS headers. We have STS HTR5, which is used for shorter strings, less than 32 bytes, right? And if it's SDS HR8, it will be used for 32 to 255 bytes strings, right? And so on. It has so many STS headers which are used for storing strings according to their bytes, right? So this flag will actually store that. So let's say it might store something like let's say 001, which is how much, right? It could be 8, so which is STS HTR8, right? So according to the values that it's storing, it would define what kind of STS HTR it's using, right? And lastly, it will store your actual string, right? So yeah, I think you might be clearer now how Redis internally stores string values. We can also discuss one example. So let's consider this example. You have name, right? So internally, if you check memory usage of this, you would see it's coming as 48 bytes. So let's discuss how this memory is actually coming, right? So we already know that every value that is stored, it's stored as redisObject, right? But we forgot to mention one thing. We are only considering the value, but what about key? So there is one more concept as well, which is KV object, which is similar to redisObject, but it stores both key SDS and value SDS, right? So basically it would be similar. So it would have again same thing. You can just copy this, right? So it would have type, encoding, LRU, reference count, pointer. So it will have two pointers now. It will have key pointer, it will have v pointer, right? So it would be STS value header, it would be key STS header location, right? It would be value STS header location, right? So let's see how storage is coming. So this whole KV object will be, I'll just write it down. So it's total, so all the objects in Redis, whether it's Redis object or KV object, it's overall let's see, it's overall 16 bytes, right? So it's fixed for Redis object or KV object, right? Now we have to define two STS, one for key, right? So key STS, so how much memory it will take, and then value STS, right? So 1 byte for the header, like whether it's STS HTR 5 or 8, right? So if it's using STS HTR 5, it will be 1 byte. If it's STS HTR 8, it would take 3 bytes, right? And yeah, you can also check it, check this one in Redis documentation if you want to, because in case of STS HTR 5, it would look something like this, where it will just have let's see, so you have length allocation flag. Okay, so in SDS HTR 5 it might store only length and the actual value, right? So it would be just 1 byte. So in case of STS HTR 5, you only have like less metadata, so that's why it's only 1 byte. In case of STS HTR 8, you have lots of metadata like length, allocation flags, so overall it will be 3 bytes, right? And then value STS, it will so most of the Redis right now they use STS HTR 8. So in this case you have fixed 3 bytes for your header, right? Now we will add the actual string, just a second. Okay, so in our case you can see key is almost 4 characters, so that means it will use 4 bytes plus 1 null terminator, right? So overall its total is 6 bytes, right? And if we round it off, it would come as 8 bytes. So why we are rounding it off? Because Redis never gives you the exact number of bytes. It always rounds it off in the power of 2, right? Because it uses internally jmalloc to assign memory, right? And similarly we will do here. So our value was 8 bytes. So as you can see, my name is almost 8 characters, so it's 8 bytes plus 1 for null terminator. So overall count is 10 bytes, and if we round it off, it would come as 16 bytes. Yeah, I think 8, 9, 10, 11. Sorry, it was 12. 8, 9, 10, 11, 12. Okay, cool. So as you can see, if we sum all these bytes, it would come as 16 plus 16 plus 8 plus 16, okay, which is 40. Yeah, so overall we need 40 bytes, but according to jmalloc we wouldn't get 40 bytes, we would get 48 bytes, right? Because it rounds off the memory. So even if you check here, you can see we got 48 bytes, right? So in this way you can see we got almost this much bytes for storing just the name, right? So yeah, in this way memory is assigned to whatever value you are storing. We can discuss one more example as well. Let's say, just a second. So let's say I I have a very big key or big value. Let's say I change my value to Yatharth Verma is good. So if you check the memory usage of this, you'll see it's 64 bytes. Now we'll see how it's coming. So everything remains same. We have a fixed Redis object size, which is 16 bytes. Key STS, it will be same because we didn't change the key at all. We only changed the value. So now value will change. So earlier it was 8. Now it would be, as you can see, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So it's overall 22 bytes plus one null character, which is let's see, 23 bytes, right? And you already know that gmalloc doesn't give you the exact bytes, so it would be rounding it off to 32 bytes, right? So if you sum all of this, it would be 32 plus 8 plus 16, which is 40. So overall it's 56 bytes, and gmalloc will round it off again, so it will be 64 bytes, right? So yeah, as you can see, so in this way you can exactly know how much memory your all string values are taking. I hope this video was useful, and if anything was not understandable, then yeah, go through the video again, and if you have any questions you can always ask me in the comments. But yeah, this is just the if we want to recap it again, every value that we store in Redis, it's stored as redisObject. redisObject stores the pointer of SDS where your actual value is stored, right? And also there is one more concept as well which I want to explain. So we already discussed, we had three encodings for strings. One was integer, one was emstrings, one was raw, right? For emstrings, what Redis does is it gives you a contiguous block of memory, and in that block you have everything. You have redisObject, you have SDS, you have your actual value, right? And so internally it would use gmalloc to assign a single block of memory, and that block will have like efficient amount of memory that would be able to contain everything like redisObject, SDS, right? So this is the case of emstring. But in case of raw string, what happens is it does two allocations. So it would, I'll just copy this one. So in this case it would do two allocations. One will be for the redisObject, and another will be for your SDS plus actual value of your string plus null terminator, right? So why in this case it's doing the two heap allocations? It's because of raw strings can be very big, and it wouldn't be able to fix in this one contiguous block. If let's say you are increasing your string value, then you already have a fixed value of your memory block here, and increasing this particular block will be very CPU extensive for the, for increasing the memory. So that's why what Redis does is it does two heap allocations. So for redisObject it's always 16 bytes, so it's always fixed. But for raw strings it gives a separate allocation in RAM, and it can vary according to string values, right? So yeah, this is just one more optimization that I wanted to tell. For raw strings, Redis does two memory allocations. So yeah, I think this video might have increased your knowledge area on how Redis internally stores strings. So yeah, that's it for this video, and next video we'll cover some more data structures. Yeah, so stay tuned. Thank you.